Hello, welcome back. This is the continuation of the previous video on aircraft materials. Okay, so until last time, we are looking at the various mechanical properties of the materials. Okay, let's get started. Now, what is resilience? Now, resilience is the property of the material by virtue of which it stores the energy and resists the shocks and impacts. The resilience of the material is measured by the amount of energy that can be stored per unit volume after it is stretched up to the elastic limit. So basically, like resilience for helmet, etc., or such kind of materials, we look at for products. We look at resilience. Endurance is a property of the material by virtue of which it can withstand various stresses and repeated applications of stresses. I can keep on using this material and then this material for a particular product, and then the loads keep coming and being applied. But then it repeated application, it still withstand for a very long period. Okay, it is the important property of the in design and the production of parts in a reciprocating machine or a component subject to vibrations. Okay, so an endurance limit or fatigue strength is the maximum stress that can be applied for indefinitely large number of times without causing any failure. The failure of a material under repeated loads is called fatigue failure. Okay, so fatigue is something very dangerous, like where the reversals of stresses are there, and then suddenly it will fail. Strength, it is the property of the material by virtue of which it resists or withstands the application of external force or load without rupture. So it tends to withstand the external force, okay, without undergoing any change. A metal has different types of strength depending upon the value of the stress. The strength of the metal can be elastic or plastic. Depending upon the nature of stress, the strength of the material can be tensile, compressive, shear, bending, or torsion. The elastic strength, it is the value of the stress or the strength which corresponds to the transition from elastic to the plastic range. Thus, the elastic limit is used to define the elastic strength of material. So, between the transition between the elastic to the plastic, that is the elastic strength. Yeah, it is something like it withstands the the elastic property. The plastic strength is the value of the stress or the strength corresponding to the plastic range and rupture. It is also called as the ultimate strength. Working stress is the greatest value of stress to which a material is subjected to as a machine part or a part of structure during operation or working. Normally, working stress is kept below the elastic limit of a material. The safety factor is something like you have the ultimate stress and then you have the working stress. So that difference or that ratio will be your safety factor. It's generally half. You know, it is trying to you have a safety factor of two times so that you uh, it'll be the working stress will be half. Tensile strength and compressive strength. Tensile strength is the maximum value of the tensile stress under the steady loads that can be that a material can withstand before the fracture or breaking. Tensile stress is equal to maximum tensile load over the original cross-sectional area. It is also called as the ultimate tensile strength. Usually, the tensile strength of a metal and alloys increases on cooling and decreases on heating. Compressive strength of a material is the maximum value of the compressive stress applied to it by to break it off by crushing. Okay, so compressive stress is the maximum compressive load. Shear strength. The shear strength of a material is the maximum value of the tangential stress applied to shear it off across the resisting section. Shear stress is equal to maximum tangential load over original cross-sectional area. When the application of an external force on a body tends to cause relative movement of the layers, shear stress is results. Bearing strength and the torsional strength. The bearing strength or the torsional strength is the maximum value of the bending stress applied to break it off by bending across the resisting section. Bending stress is equal to the maximum bending load over original cross-sectional area. The torsional strength of the material is the maximum value of the stress applied to break it off by twisting across the resisting factor. This one is is torsional load, whereas this one will be the bending load. Okay, and torsional stress is equal to maximum twisting load over original cross sectional area. The twisting stress is torsion. Creep. Now, creep, it is defined as the tendency of the material to slowly deform permanently and under influence of the stress. Like the bell, etc., they're hanging on a church wall. The same load is there, self weight is there. Over a period of year, it tends to yield. And this yielding or increase of strain without increase in load may continue to a point of fracture. The rate of deformation depends on the exposure, time and temperature. Usually creep occurs in high temperatures. This property is exhibited by iron, nickel, copper and their alloys at elevated temperatures. But zinc, tin, lead and their alloys show creep at room temperature. In metals, creep is a plastic deformation caused by slip occurring along the crystallographic planes. This plane, the shear plane, like if I have to show you like this is shear plane. After complete release of load, a small fraction of this plastic deformation is recurred with time. Thus, most of the deformation is non-recoverable. Creep limit is defined as the maximum static stress that will result in creep at a rate lower than some assigned rate at a given temperature. Now, there are various stages of creep. You have the primary creep, the creep, the secondary creep, and the tertiary creep. Okay, so during the elastic time, there is no strain that happens, and slowly the strain happening during the primary creep, and then there is a secondary creep at that time. It tries to hold on to the drastic deformation, and once it enters the tertiary creep, then it goes faster, and then finally the failure occurs. Okay, so this is what is the stages of creep, and I think we have come to the last slide on this thing. This is how the various the pictures of the fracture, etc. Brittle failure will have an abrupt failure here, and this is a ductile failure where there is a kind of an elongation when it fails, and then you have the creep failure here over a period of time. There's a creep failure, and then the fatigue failure that happens over the surface of the body. Okay, we will. This is what is the various properties, mechanical properties that any aircraft designer must know, and so that is how we have checked all the various properties that is required, desirable properties of metals that is being used in aircrafts. Okay, thank you very much. We'll meet again on another this one. Um,